Okay, let's take a look at this. Let's see. First problem says, while hovering near the top of the waterfall in a national park at 6,400 feet, a helicopter pilot accidentally drops his sunglasses. The height h of t of the sunglasses after t seconds is given by the polynomial function h of t is equal to negative 16 t squared plus 6,400. When will the sunglasses hit the ground? Now, if h is our height after t seconds, that means that when will it hit the ground? That means when is the height 0? So I'll put 0 in for that. Now in this one, I'm going to take negative 16t squared to the left side. It becomes a positive 16t squared equals 6,400. I'll divide both sides by 16. And, 400? Better check. 6,400 divided by 16. 400. And then the square root property says if you got something squared equals something else, you drop your squared and you put a plus or minus square root on the other side. And 20 times 20 gives you 400, so this gives me plus or minus 20. Now you can't have a negative time, assuming t is time, after t seconds. So that means that our answer has to be t is equal to 20. And on to the next problem. Let me clear this off. It says Marie has a rectangular board 18 inches by 24 inches around which she wants to put a uniform border of shells. If she has enough shells for a border whose area is 288 square inches, determine the width of the border. Okay. I'm not sure if I'm reading this right. That's 24. This is 18. Now we're going to have a border around this. And this border is going to be x there. And that's this distance here. And it'll also be x here. Okay. Let's put a uniform border. If she has enough shells for a border whose area. This specifically says the area of the border is 288. Okay. The area of the border will be all of this. When I started reading the problem, I fully expected it to be the area of the entire piece. Okay, so let's look at this piece here, this rectangle. It happens to match this rectangle down here, so we have 2 times that size. And again, I'm working with this rectangle going all the way across here. So this distance here is x. Now if this distance is 24 and this distance is x and this distance is x, then this distance will be, and I shouldn't put an x there, I should put 2 times this. But this x is x, this is x, and this is 24. So this total distance here is going to be 24 plus 2x. So the area of that is going to be 2 times this distance times this distance. So x times 24 plus 2x. So that is going to be area is equal to 2x 24 plus 2x. Now let's go ahead and multiply that through. I think I'm going to need to. 2x times 24 is 48x. 2x times 2x is 4x squared. That's the distributive property. Now we're going to look at that first rectangle was this right here. And I had two of them because there was one down here the same size. Now my next one is going to be this right here, this rectangle, and this rectangle, which happen to be the same. Okay, let me do it up here. So I'm going to have two of them. So 2 times, and if this distance is 18 and this distance is x, then I'm going to have, let's see, 18 here and x here. So the area is going to be 2 times 18 times x. So the area is going to equal to 36x. Now together, these two areas have to add up to equal 288. So I'm going to have 48x plus 4x squared plus 36x equals 288. Okay, so we got 4x squared, 48 plus 36. What world is that? 48 plus 36, 84x. And I'll bring the 288 over, minus 288 equals 0. Now I can factor a 4 out, and that gives me x squared plus 21x minus 72 is equal to 0. Is that factor? Let's see, 72, 1 times 72, 2 times 36, 3 times 24, there it is. So this factors as x plus 24 times x minus 3 using the PSD method. Now, I don't need to worry about 4, but I'll set the x plus 24 equal to 0 and the x minus 3 equal to 0. Now here, if I take 24 over, it becomes a negative 24, and here if I take the 3 over, it becomes a positive 3. You can't have negative distance, so the only one that makes sense is this one right here. Now what they're asking is, what is the width? Determine the width of the border. So they want to know this x here. So since we found x, then the answer would be 3. Is everything in inches? Inches, square inches, everything's in inches, so that's good. Now write the number in scientific notation. Okay, let's clean this off. And I got 0.0131. Now we want our first digit to be a number between 1 and 9. So I'm going to move this 2 places to the right. So that'd be 1.31 times 10. And since I moved it to the right, it's going to be a positive 2. Wait a minute. Negative 2. So we're going to use the multiplication symbol. 1.31. I would have done x. I probably would have got that one wrong. So there's your times. Why didn't that appear? Oh, there it is. Okay. And 10 to the negative 2. Okay, solve the equation. Let me clear this off. We got y to the third is equal to 144y. And it wants us to solve this. So I'm going to take the 144y to the left side. It becomes a negative 144y. When you're solving polynomial equations, you have to get 0 on one side. Even quadratic equations, you have to get 0 on one side. Now right away I notice that they both have a y, so I can factor out a y. And that gives us y squared minus 144. That's GCF. We factored the y out. Now looking at what's inside the parentheses, I notice there's two terms with a minus between it. That's difference two squares. So it factors as y times y plus 12, y minus 12 equals 0. You could have also used the square root property. Now 0 on one side, you factored the other side, you said each factor equal to 0. So I said y equal to 0, y plus 12 equal to 0, and y minus 12 equal to 0. So we got y is equal to 0, take 12 over, y is equal to negative 12, take negative 12 over, y is equal to positive 12. Okay, solution is type an integer or simplified part. Use a comma to separate answers as needed. Okay, 0, negative 12, and positive 12. Now let me clear this off. And I got 25x squared minus 30x plus 9. Now this is the key number, although you could also use the it's also a perfect square once it works out. But if we take the number at the beginning times the number at the end, ignoring signs, I got 25 times 9. That gives us 225. Yeah, 225. We come up with our three columns. Write down all products, give us 225. 1 times 225, 2, no, 3 times 75. 4, no, 5 times 45. No, is that right? 5, 2, yeah, that's right. 6, no. 7, I don't think so. 8, no. 9, no. 10, no. 11, no. 12, I don't think so. Okay, now I'm drawing a blank. 225 divided by 12. 225 divided by 13. I bet it's 15. 225 divided by 14. 225 divided by 15. Yeah, 15 times 15. Now if I add these, 1 plus 225 is 226. 3 plus 75 is 78. 5 plus 45 is 50. 15 plus 15 is 30. And subtract them. 225 minus 1 is 224. 75 minus 3 is 72. 45 minus 5 is 40. 15 minus 15 is 0. Number we're looking for is a number in a middle term, which is 30, which is right here, which means we use 15 and 15. Now we're going to rewrite our middle term using those two numbers. Our larger number, which are both the same, so we'll choose 115, is going to be the same sign as the middle term, which is negative. The number I circled in the S column, S for same sign, so if one of them is negative, the other one will be negative. Then I'll factor by grouping. First group has a 5 and an x in common, and that gives us 5x minus 3. Second group, the first term is negative, so I bring out a negative, and they're both divisible by 3. And that gives us 5x minus 3. Now our goal was to get this parentheses same as this parentheses, which they are, so I'll factor it out. And that leaves us 5x minus 3. Oftentimes how that's written is 5x minus 3 squared. What does this say? Factor completely. I wonder what kind of form it wants. Let me put 5x minus 3 squared. Okay, I want to factor this. Let me clear this off. And we got 54 v squared minus 150. And factor it. They're both least divisible by 2. I feel like there's more than that because they're both also divisible by 3. 6. Okay, so my GCF will be 6. So that'll give us 9v squared minus 25. That's GCF. Now, what's inside the parentheses is 2 terms of minus between it, so I use difference 2 squares. Now, with difference 2 squares, remember we try to write it as something squared minus something else squared. 3 times 3 is 9, v times v is v squared, and 5 times 5 is 25. So we take what's inside our first set of parentheses, the 3v, we add what's in our second, and then we take what's inside our first set of parentheses, the 3v, and we subtract what's in our second, which is the 5. So we're going to have 6 times 3v plus 5 and 3v minus 5. Now let's take a look at our next problem. We got x minus 3 squared plus 2 times x minus 3 minus 8. Now this is best done with a method called a U-Substitution. What makes me think this is because if you can take the middle part here, which is x minus 3, raise it to the second power and it gives you this first part, that's when you can do the U-Substitution. Now I'm going to let the middle part here be equal to u, and the first part be equal to u squared. And that's our first step. So we're going to end up with u squared plus 2u minus 8. Then step 2 is to factor this like normal. And this would be the PSD, because we got u squared, u, no u, and there's no number in front of our u squared. So we take the number at the end, the 8, and then we're going to come up with our 3 columns. We'll write down all products to give us 8. So we got 1 times 8, 2 times 4. Add them. 1 plus 8 is 9, 2 plus 4 is 6. Subtract them. 8 minus 1 is 7, 4 minus 2 is 2. The number we're looking for is a number in our middle term, which is 2, which is right here, which means we'll use 2 and 4. Now our larger number that we're going to use is the 4. It'll always be the same sign as the middle term, which is positive. The number we circled is in the difference column, D for different signs. So if the 4 is positive, then the 2 has to be negative. Then step 3 of the U-Substitution. Plug u equals blank back in. So we said u is equal to x minus 3, so we'll plug that back in. So we got x minus 3 plus 4, and x minus 3 minus 2. Negative 3 plus 4 is 1, so we got x plus 1. And this one, negative 3, negative 2 is negative 5. So we're going to have x plus 1 times x minus 5. Now here we want to add these polynomials together. Okay, so we got negative 5x plus 8 plus negative 2x squared plus 5x minus 2. Now these parentheses aren't doing anything because there's no numbers in front of them, no negatives, so we can drop them. And then we just combine like terms. So we got negative 2x squared. Here's negative 5x plus 5x. That cancels. Is that true? Negative 5x plus 5x. I guess they are the same, or, well, different signs. And then 8 minus 2 is 6. So that'd be our answer. So I got negative 2x squared plus 6. And we want to factor this. So we got x squared minus 11x minus 80. And this would be the PSD. Reason why is because we got x squared, x, no number in front of our x squared. PSD would take our number at the end, the 80, and we're going to come up with our 3 columns. We write down all products give us 80. We got 1 times 80, 2 times 40, 3, no, 4 times 20, 5 times 16? Yeah. 6, no, 7, no, 8 times 10. I think that's all of them. Now add them. That's what the S column is. 1 plus 80 is 81. 2 plus 40 is 42. 4 plus 20 is 24. 5 plus 16 is 21. 8 plus 10 is 18. Subtract them, smaller from larger. 80 minus 1 is 79. 40 minus 2 is 38. 20 minus 4 is 16. 16 minus 5 is 11. 10 minus 8 is 2. Number we're looking for is a number in the middle term, which is 11, which is right here, which means I use 5 and 16. Now our larger number that we're using, which is a 16, will always be the same sign as the middle term, which in this problem is negative. Number I circled in the difference column, D for different signs, so if this one's negative, this one has to be positive. So we got x plus 5 and x minus 16. Now this next problem, we're going to multiply these together. So we got 11 x to the 4th plus 6 times 11x squared plus 7. So I'll take my first term here, the 11x to the 4th, and multiply times each term over here. And I'll take my second term in the first set of parentheses and multiply times each term over here. So I'll follow the line to see what to multiply together. So we got 11x to the 4th times 11x squared. We got 11x to the 4th, and I'm just following these lines, times 7. And then we got 6 times 11x squared. And we got 6 times 7. Now 11 times 11 is 121. And x to the 4th times x squared, you add the exponents, that gives us x to the 6. 11 times 7 is 77 x to the 4th. 6 times 11 is 66 x squared plus 42. Simplify your answer, do not factor. 121 x to the 6 plus 77 x to the 4th plus 66x squared plus 42. Just double check that. 66, yeah. Okay, factor the following polynomial. You clear this off. I got xy plus 3y minus 8x minus 24. First off, there's no GCF, so I have to do factoring by grouping because there's 4 or more terms. Now my first group has a y in common, and that leaves us x plus 3. Second group has a negative 8. They're both divisible by 8, and the first term is negative. And that leaves us x plus 3. Now our goal was to get these parentheses the same, which they are, so I factor out an x plus 3, and then that leaves us y minus 8. So x plus 3, y minus 8. And solve this equation. I realize I used the square root property earlier. I probably shouldn't have done that because I realize it's probably not covered in this chapter. But you would just factor it using whatever technique instead of the square root property. Difference 2 squares, if I had to guess. That was where I had like x squared is equal to 400. You take the 400 over, and it becomes x plus 20 times x minus 20. Okay. On this problem, we want to solve the equation, and you have to have 0 on one side. So I'm going to take that 18, move it over. So I got w squared minus 3w minus 18 equals 0. Now this will factor using the PSD, because we got w squared, w, and there's no number in front of our w squared. So we take our number at the end, the 18, ignoring signs. Then we'll come up with our 3 columns. So we'll write down all products give us 18. We got 1 times 18, 2 times 9, 3 times 6. We want to add those. 1 plus 18 is 19, 2 plus 9 is 11, 3 plus 6 is 9. Subtract them, smaller from larger. 18 minus 1 is 17, 9 minus 2 is 7, 6 minus 3 is 3. Number we're looking for is a number in our middle term, which is 3, which is right here, so we're going to use 3 and 6. Now our larger number that we're using, which is 6, will always be the same sign as the middle term, which is negative. Number I circled in the difference column, D for different signs, so if this one's negative, this one has to be positive. Now the zero factor property. You get 0 on one side, you factor the other side, you set each factor equal to 0. So I'll set w plus 3 equal to 0 and w minus 6 equal to 0. And that gives us w is equal to negative 3 and w is equal to 6. Okay, solutions are type an integer, use a comma, separate answers as needed. So negative 3, comma 6. Let's take a look at this problem. We got 2a to the third, b, c to the negative 7, raised to the negative 5 power. First off, order of operations says do what's inside the parentheses. So let's focus on what's inside the parentheses. Inside the parentheses, I notice I got a negative exponent. We don't like negative exponents. So I'm going to put this over 1. Now how you get rid of a negative exponent, in this case, is you take it opposite of where it's at in a fraction. So we'll take this c to the negative 7 down to the denominator. When you move anything opposite of where it's at in a fraction, the sign of the exponent changes. So the c to the negative 7 becomes c to the positive 7. Now there's nothing left to do inside the parentheses. So now we're going to focus on this negative 5 here. Whenever you have a fraction to a negative power, you flip the fraction, take reciprocal of it. So that becomes c to the 7th over 2a to the third b. And then you change the sign of the exponent to positive. So it just changes signs. Now it should be called the distributive property of exponents. It's not, but if everything inside your parentheses is either multiplication or division, and you're raising it to a power, then you take everything inside individually to that power. Notice how I got c to the 7th divided by 2 times a to the third times b. So everything is multiplication or division. So we're going to take the c to the 7th to the 5th power, the 2 to the 5th power, the a to the third to the 5th power, and the b to the 5th power. So we're going to have c to the 7th to the 5th. We'll have 2 to the 5th, a to the third to the 5th, and b to the 5th. Now when you raise one exponent to another exponent, you multiply them together. So 7 times 5 is 35, so we're going to have c to the 35th. 2 to the 5th is 32. A to the 15th, b to the 5th. And that's our answer. Fraction. Okay, top part, we got c to the 35th. On the bottom, we have 32, a to the 15th, b to the 5th. Let me clear that off. This one's kind of an interesting one. X plus 2 plus 8a x plus 2. It's kind of a tricky one. It says factor out the greatest common factor from the following polynomial. Well, this has an x plus 2. This one has an x plus 2, but it doesn't appear like there's anything else with it. But if I were to put something with it, there's a 1 in front of that, if I were to put it inside of parentheses like that. So now they both have an x plus 2, so I'll factor that out in front. Now to see what goes in your second set of parentheses, you can now go up the previous and cross out the x plus 2's. And what isn't crossed out is what goes right here, which would be 1 plus 8a. It's very easy to overlook that 1. Now, I'm not sure if they want it in standard form or anything. Doesn't say. I'm going to reverse that. I'll put 8a plus 1, just because I'm not sure what they're looking for. Okay. Let me clear that off. Then we got 12x squared plus 13x minus 4 equals 0. And want to solve it. Well, first thing, you have to have 0 on one side, which we do. And then you have to factor the other side. This factor is using the key number. The reason why is because we have x squared, x, no x, and there's a number in front of x squared. So with the key number, we're going to take the number at the beginning times the number at the end, ignoring signs. I say the number at the beginning, I'm talking about the number in front of the x squared. Number at the end is the constant term, the 4. Again, ignoring signs. And that's going to give us 48. We'll come up with our 3 columns. We'll write down all products give us 48. We got 1 times 48, 2 times 24, 3 times 16, 4 times 12, 6 times 8. Add them. 1 plus 48 is 49, 26, 19, 16, 14. Subtract them, smaller from larger. 48 minus 1 is 47, 22, 13, 8, and 2. The number we're looking for is a number on our middle term, which is 13, which is right here, which means we use 3 and 16. Remember the key number, we're going to rewrite our middle term using those two numbers. The larger number that we're using, which is a 16, will always be the same sign as the middle term, which is positive. Number our circles in the difference column, D for different signs. So if the 16 is positive, the 3 has to be negative. Then we'll factor by grouping. First group has a 4 and an x in common, and that gives us 3x plus 4. Second group doesn't have anything in common, but first term is negative. And if your first term is negative, you always factor out a negative. So we'll factor out a negative 1, and that gives us 3x plus 4. Now our goal was to get these parentheses same, which they are. So I'll factor out a 3x plus 4, and that gives us 4x minus 1. Zero factor property. Get 0 on one side, you factor the other side, you set each factor equal to 0. So we got 3x plus 4 equal to 0, and 4x minus 1 equal to 0. Now here I'll take the 4 over, it becomes a negative 4, divide both sides by 3, and we get negative 4/3. Here I'll take a negative 1 over, it becomes a positive 1, divide both sides by 4, and we get 1/4. Okay, so the solutions are, type an integer or simplified fraction, use a comma to separate the answers as needed. So we'll have negative 4/3, comma, 1/4. Let me clear this off. And we got negative 4, x to negative 4. Now right away, and simplify, use positive exponents. Even if it didn't say that, we can't have negative exponents. So I want to throw this over 1, because remember earlier I said how we get rid of a negative exponent is you move the part that has a negative exponent opposite where it's at in a fraction. So I'll take that x to negative 4 down below. Now the negative 4, the coefficient that was right here, we leave up on top. We have nothing wrong with negative numbers. It's the negative exponents we don't like. So I take the x to negative 4 down below, and it becomes x to positive 4. So that gives us negative 4 over x to the 4th. Okay, I want to factor this. $25 y squared x squared plus 40 yx squared plus 16x squared. Let me grab a drink here. Right away I notice they all have an x squared. So I can factor out a GCF of x squared. And that gives us 25y squared plus 40y plus 16. Now I'm going to factor what's inside here with a key number, although you could use a perfect square technique. The reason why I use key number is because you got y squared, y, no y, and there's a number in front of our y squared. So we'll take our number at the beginning times the number at the end, ignoring signs. So 25 times 16. 25 times 16 gives us 400. And we got 1 times 400, 2 times 200, 4 times 100, 5 times 80, 6 no, 7 no, 8 times 50, 9 no, 10 times 40, 11 no, 12, just real tempted to skip down to the answer, but that would imply that you could just see the answer. So let me try these. $400 divided by 16. We don't get, oh, there's one. 16 times 25. And 400 divided by 17. 400 divided by 18. See, and that's assuming I could see the answer. I can see the final answer, but I'm not sure if I can see the steps in between, if that makes any sense. And 400 divided by 20, which is one I was thinking it was going to be, but maybe it's not. So that's 20 times 20. And it is. 20 plus 20 gives us 40, which is right there. So we're going to use 20 and 20. Now we're going to rewrite our middle term using those two numbers. A larger, but they're both the same, so you pick an 80-20, is always going to be the same sign as the middle term, which is positive. Number with circles in the S column, S for same sign, so this other one will be positive too. Then I want to factor by grouping. First group has a 5 and a y in common, and that gives us 5y plus 4. Second group are both divisible by 4, and that gives us 5y plus 4. Now they both have a 5y plus 4, so I'll factor that out. Now to see what goes in your second set of parentheses, you can go up the previous step and cross out those 5y plus 4s you factored out. And what isn't crossed out is what goes here, which is also a 5y plus 4. So this is going to be x squared times 5y plus 4 squared. Okay, so we got x squared, 5y plus 4 squared. Let's take a look at this one. So we've got 10x to the negative 6, z, or y, z to the negative 4. Okay, let's see if I wrote it down correct. 5x to the 4th, yz. And I want to simplify it. Well, right away we notice we got negative exponents. We don't like negative exponents. So I take this z to the negative 4 down below. I'll take this x to the negative 6 down below. So I'm going to have 10y over 5x to the 4th. Now bring the x to the negative 6 down, it becomes x to the positive 6. Y, z, and this z to the negative 4 becomes z to the positive 4. Now right away I notice I have a y here and y here, so those are going to cancel. Now 10 and 5 are both divisible by 5. 10 divided by 5 is 2, 5 divided by 5 is 1. Now if you got x to a power times x to a power, you add the exponents. 4 plus 6 is 10. And here, there's like a first power here. So 1 plus 4 would give us z to the 5th. So our answer would be 2 over x to the 10th, z to the 5th. Okay, so 2 over x to the 10th, z to the 5th. Let me just double check. Okay, that looks good. Find the product. Let me clear this off. And we got 9x plus 7 squared. Now 9x plus 7 squared means 9x plus 7 times 9x plus 7. You cannot just square the 9x and square the 7 because of the plus in there. Everything would have to be multiplication or division for you to do that. So we're now going to take 9x times 9x, 9x times 7, and then we'll take 7 times 9x and 7 times 7. So we'll follow our lines. That's also FOIL, because we've got two terms and two terms. So 9x times 9x, we'll have 9x times 7, we'll have 7 times 9x, and 7 times 7. It gives us 81x squared plus 63x plus 63x plus 49, which gives us 81x squared plus 126x plus 49. So we get 81x squared plus 126x plus 49. And write the number in scientific notation. So we got 65,022. Now if our word put a decimal here, it'd be right here. And for scientific notation, we want just one digit between 1 and 9. So I have to move this to the right. 2, 3, 4 places to the right. So this would be 6.5022 times 10. 1, 2, 3, 4 places. Fourth power. Okay, so 6.5022. And make sure you use the multiplication down here, not x. 10 to the 4th. Now in this one, it says write the number in standard notation without exponents. That's interesting. 7.44 times 10 to the 11th. What that 10 to the 11th means is you move decimal point 11 places to the right. So we've got 2 of them here, and then we have to add on 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we got 7, 4, 4, 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I typed them all in correctly. Okay, let's take a look at this one. We got 20 x to the 3rd y squared minus 28 x squared y squared. First off, they're 20 and 28. I guess they're both divisible by 4, so I can bring a 4 out. We can bring out 2 x's. It's always the one with the smallest exponent. This is the 3rd power, this is the 2nd power, so we bring out x to the 2nd power. and then we'll bring out a y squared. This is GCF. 20 divided by 4 is 5. We had 3 x's, we took 2 of them away, so it leaves a single x, and those y squareds are gone. Minus 28 divided by 4 is 7. That x squared's gone, that y squared's gone, so that would be our answer. So we've got 4x squared, y squared, 5x minus 7. What the world is this one saying? I think they're conjugates each other, but let's see. Minus 2s. I hate s's. Minus 5, because my s's look like 5s. Plus 2. And negative 2s minus 5 minus 2. They are conjugates. Now, a nice part about conjugates is, why it's conjugate is this is my first part, that's the same as the first part here. This is my second part, and it's the same as the second part here. But the sign in between them is different. Nice part about conjugates is all you have to do is multiply your first parts together. So we'll take negative 2s minus 5 times negative 2s minus 5. And then we'll multiply the last parts together. So we'll have 2 times negative 2. Negative 2s times negative 2s gives us a positive 4s squared. Negative 2s times negative 5 gives us a positive 10s. Negative 5 times negative 2s is a positive 10s. Negative 5 times negative 5 is 25. And 2 times negative 2 is negative 4. Which gives us 4s squared. 10s plus 10s is 20s. And 25 minus 4 is 21. So 4s squared plus 20s plus 21. 4s squared plus 20s plus 21. Solve the equation. You clear this off. Then we got y squared plus 9/4 is equal to negative 3y. Now, first off, it doesn't matter where we are in math. If you're solving an equation, you always want to get rid of fractions. I think that's a true statement. Every situation I can think of, you do. So we're going to multiply everything by the LCM of all the denominators. So we'll multiply everything by 4. So we got 4 times y squared, 4 times 9/4, and 4 times negative 3y. So that's going to give us 4y squared. These 4's cancel. We've got 9 equals 4 times negative 3 is negative 12y. Now to solve, you need 0 on one side. So I'm going to take the negative 12y over, becomes a positive 12y plus 9. Now we're going to factor this using the key number. You could also use the perfect square method. Key number because we've got a y squared, y, no y, and there's a number in front of our y squared. So we're going to take our number at the beginning times the number at the end, ignoring signs. So I got 4 times 9, which is 36. We got 1 times 36, 2 times 18, 3 times 12, 6 times 6. And 6 times 6 is what gives us our 12 when we add them together. 6 plus 6 is 12. So we're going to rewrite our middle term using those two numbers. The larger number, they're both 6, so I'll pick a 6, is always going to be the same sign as middle term, which is positive. Number we circled in the S column, S for same sign, so if this 6 is positive, the other one will be positive too. Now factor by grouping. My first group has a 2 and a y in common, and that gives us 2y plus 3. My second group are both divisible by 3, and that gives us 2y plus 3. Now our goal was to get this parentheses same as this parentheses, which they are, so I'll factor it out. Now we're solving these, but they're both the same. So I'm going to set one of them equal to 0. And we get 2y is equal to negative 3. Divide both sides by 2, and we get negative 3/2. I'm pretty sure it doesn't want you to write it twice. Let's see if I get it wrong. Famous last words. Okay, let's take a look at this problem. Okay, so we got 7x to the 7th, y to the 6 to the negative 1 power, and we got 8, x to the 6, y to the 8th. 7x to the 7th, y to the 6, negative 1, 8x to the 6, y to the 8th. Okay. If we followed our order operations, do what's inside the parentheses. There's nothing to do inside the parentheses. Please excuse exponents. Well, there's exponents all over the place, but I can't do anything with the 7, the 6, the 6, and 8 here. But that negative 1 bothers me. Well, if I put this over 1, then we're going to have a fraction. So we'll have 7x to the 7th, y to the 6 over 1 to the negative 1 power. And I'll go ahead and put this over 1 while I'm at it, because we're going to be looking at fractions here pretty soon, and it's helpful if they're both fractions. Now, we already talked, if you have a fraction to a negative power, you can flip the fraction, take reciprocal of it. So we got 1 over 7x to the 7th, y to the 6, and the sign of the exponent becomes positive, so it becomes a positive 1. And then 8x to the 6, y to the 8th over 1. Oops. Now that first power here doesn't do anything anymore, so we'll go ahead and multiply these together. 1 times that gives us 8x to the 6, y to the 8th. And 7x to the 7th, y to the 6 times 1 just gives us 7x to the 7th, y to the 6. Now 8 and 7 I can't do anything with, but here I got x to a power over x to a power. We're going to subtract the smaller exponent from the larger one. 7 minus 6 gives us 1. So we're going to have x to the first power where our larger exponent was, which is on the bottom. Now for our y's, we're going to have 8 minus 6, which is 2, which means we'll have y to the second power where our larger exponent was, which is on top. So that's going to give us 8y squared over 7x. 8y squared over 7x. Let's clear this off. We've got x to the 4th plus 8x to the 3rd. And was it factor? Yeah, factor. Well, I notice they both have an x to the 3rd, so GCF-wise I can factor an x to the 3rd. And that leaves us x plus 8. That seems too easy. Assuming you recognize it's a GCF. X to the 3rd, x plus 8. Factor out the greatest common factor. Okay. So we got 12 b to the 3rd plus 3b squared plus 2. What in the world are they talking about? Factor out the greatest common factor. There's no greatest common factor. Some of them have b's. Some are divisible by 3. Some are divisible by 2. If you look at all three terms, they don't have anything in common. So a polynomial has no common factor other than 1. Okay, must be a trick. I mean, trick as if it's prime. Means you can't factor it. Either that or it's just too late and my eyes crossing. 2a plus 6. Okay, we want to multiply these together. So I'm going to take a times 2a. I'll take a times 6. Is that a negative 4? Yeah, negative 4 times 2a and negative 4 times 6. A times 2a is 2a squared. A times 6 is 6a. Negative 4 times 2 is negative 8a. And negative 4 times 6 is negative 24. So we're going to have 2a squared, 6a minus 8a, combine like terms. That gives us negative 2a minus 24. So we've got 2a squared minus 2a minus 24. Let me grab a drink here. Moment of truth will be coming up pretty soon. See how many I got right. How many I got wrong. A lot of people think math instructors are do not make any mistakes, but that's not true. All of our I's cross at some point. 27 a to the 5th, b to the 3rd, plus 64 a to the 8th. Factor the following. Okay, GCF. What do they have in GCF? Looks like they have an a to the 5th in common. And that gives us 27 b to the 3rd plus 64 a to the 3rd. Remember, if they both have a to a power, you bring out one of the smallest exponents. That's why we bring out a to the 5th. Here we had 8 a's. I took 5 away, so there's 3 a's left. Now this is a sum of 2 cubes. So I'm going to try to write this as something to the 3rd power plus something else to the 3rd power. And you ask yourself, what times itself 3 times gives each individual piece? For example, 27 is 3 times 3 times 3. B to the 3rd is b times b times b. 64 is 4 times 4 times 4. And a to the 3rd is a times a times a. Now I'm going to label these. This is what's in my first set of parentheses. This is what's in my last set of parentheses. The formula for the sum of 2 cubes is f plus l times f squared minus fl plus l squared. So the a to the 5th carries down. Now everywhere there's an f, I'll plug in 3b, and everywhere there's an l, I'll plug in 4a. So we're going to have 3b plus 4a, and then we'll have 3b squared minus 3b times 4a plus 4a squared. So that gives us a to the 5th times 3b plus 4a. 3b squared. 3b times 3b gives us 9b squared. Minus 3 times 4 is 12, and b times a is ab. And 4a squared gives us 4a times 4a, which is 16a squared. So we don't get my a's messed up with 9s. Let's see, a to the 5th, 3b plus 4a, 9b squared minus 12ab plus 16a squared. 9b squared minus 12ab plus 16a squared, 3b plus 4a. Okay, that looks right. Let's take a look at this one. I got 5, x to the negative 11, x to the 3rd, over x to the negative 8. Well, first off, we don't like negative exponents, so let's handle those. I'm going to take this x to the negative 11 down below, and I'll take this x to the negative 8 up on top. Now, when you move anything opposite where it's at in a fraction, the sign of the exponent changes. So this x to the negative 8 becomes x to the positive 8. This x to the negative 11th becomes x to the positive 11th. Now, if you have x to a power times x to a power, you add the exponents. 3 plus 8 is 11, so we got x to the 11th. Now, since we have x to the 11th on top and bottom, so those are going to cancel, and our answer is 5. Okay, perform the indicated operation. That's 6,000 times 0.006 and 0.009 times 200. Now we could rewrite these in scientific notation and handle it that way. Or you could just plug them in your calculator. So it's kind of up to you. 6,000 times 0.006. The idea of rewriting them in scientific notation is make your life easier. Well, I don't think it'd be easier. 0.009 times 200 gives us 1.8. Now 36 divided by 1.8 gives us 20. But what they want their answer in says use scientific notation, use a multiplication symbol, and math palette as needed. If I were to put a decimal, it's right here, so I'd move it to the left. So this would be 2.0 times 10 to the first power. The question will be how they want that written. Technically speaking, let's see if I get this one wrong. I put 2.0 normally. I do a times, and then I do 10 caret 1. But they may just have a 10 there, or they may just have 20. We'll see. And last problem, subtraction. So I got 7x squared plus x plus 6 minus 3x squared minus 4. Now, this first set of parentheses isn't doing anything, so I can drop it. Now, remember, if you have a negative in front of your parentheses, this flips the sign of everything inside. So the positive 3x squared becomes a negative 3x squared, and the negative 4 becomes a positive 4. Now, 7x squared minus 3x squared is 4x squared plus x, and then 6 plus 4 gives us 10. So, let's see. 4x squared plus x plus 10. Here's a moment of truth. Submit the test. Oh, I like to see that. No mistakes. I don't always get that lucky. But that's the review.